indexing. Sample Python project and tell us more about it. Okay, okay. After the class, we'll discuss the things. Okay, fine. So indexing is very much clear to you all. I believe that these things are clear, right? So if I just write up, let me first quickly write or import things. Okay, fine. So if I write that x is equals to np dot arrange of, let's say, 10, and if I say that I want to slice some numbers, so like 1 to 8 in intervals of 2, so I'll be getting the slicings of x with 1 to 8 to 2, right? So what I want to slice, I want to slice this x like this. Okay, so even if I write up the same things at like 1 to 8 in the intervals of 2, we get getting the same elements, that is the slice function working here. Okay, fine. At the basic, the slicings will be very easy, right? That is 0 of 0, 1 and all. Okay, so indexings and the slicings. Okay, fine. So we'll just take an array and then we'll make you see how indexing works and what exactly I'm talking about. Okay, so let's say this is x equals to a numpy dot array, where this is a two-dimensional array, and I'll be writing this as 10, 12, 20, 14, and then it could be 60, 30, and 16. Okay. Voices in? Yeah. Okay, fine. So this is y, which will be equals to. Now I'm going to slice up the things, and I'm saying that this will be, let's say, 0, 1, 2, and this is going to be 0, 1, 0. Okay. Well, that's nice, and we'll just print up the x. So x is 10, 12, 20, 14, and 13, 16. Sorry, 30, 16. Right. Now, what is my y? What is going to be my y? It is 10, 14, and 30. And how this is 10, 14, and 30? So can you find up the patterns and what exactly I have done in the y? So in the y, I am searching for 0, 1, 2, and that 2 of 0, 1, 0. That means that 0 of 0, 1 of 1, and the 2 of 0. Means that the first row and the first column. So this total thing is the x, right? So what is the first row? This is first row. And what is the first column? That is 10. And you have seen 10 here. Next, you have written the second row and the second column. So this is the second row and the second column, 14 outcome. And then the third row and the first column. So the third row and the first column to be 30. So 10, 14, and 30. Clear to everyone? So 0 of 0, 1 of 1, and the 2 of 0. Fine. That is indexing over there. I think I'll be clear to you. Right? Okay. Fine.
Sir, can you just tell this part? It was a little confusing. The 0, 0, 0, 1 part which you said right now.
Okay. See, here what you are getting is, first you are getting x of 0, then you are getting x of 1, and then you are getting x of 2 of 0. First is the x of 0, then 1 of 1, and then the 2 of 0. That's it. That is 10, 14, and 30 respectively.
Got it.
So let's take x another array as okay, and let's just take to be a 2 dimensions, and it would be like 10, 11, 12, okay, 14, 15, 15, 16, 17, 18, 19, 20, 21. Okay, so this is going to be my x. So if I see my x, it would be 10, 11, 12, 13, 14, 15, 16, 17, 18, and 19, 20, and 21. Alright, now, so what I mean to say that using this, if I'm going to check that print in the x where my values in the x where my x values are like let's say equals to 4, nowhere, right, where the values are greater than 4. So all these are the values which are greater than the 4, starting from 10. So where the values are greater than 20, so only one value is there, that is 21 inside the x. Where the value is greater than 15, so these are the values in your array which are greater than 15. Okay. Alright. So what if you write only that x is greater than 15? There you'll be getting some discrete values, boolean values, false, false, true, 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 and all those, right? So what you do is you convert this. How many values are there? You can just see. You can just search on for the true. That is x greater than 15. So what you can do is after this you can write it to list, and that will be an array. Okay, that is a list now, and you can then count off that how many true occurrences are there. So 1 minute. Let's say this is S. False, false, false. Okay, is it converted? Okay. So I could see the last 6 elements to be true, right? If I just write the last 2 elements, right? That is -2 and then -1. So I'll be getting it as true things, right? So till -2, everything to be printed up, and that's it. The true objects, right? So 6 true objects are there, and here also you could see up there that is 1, 2, 3. So here you could probably see the numbers exactly what is there, and there you can find out the true things, and then you can find out the index and all, and you can go with that respectively. All right. So if the s of true -2 is something like this, then the array of -2 will be working. All right. Fine. So similar to this, if I write that x is equals to np dot an array where the numbers are also a nan, that is there is some nan values 30, 40, okay, so some nan numbers and only 2 arguments and keywords are to be expected. Alright, so this is my x. Okay, now if I just print my x, you will see up the values quickly. So 10, 20, nan, 30, 40, and nan. Now, if I want to see how many, like, let's say if you have a multiple data sets when you will be working in the pandas, we'll be having some multiple data sets for analyzing things, and they will be seeing this. You're having some NaN values even more than even you are having very null values. You say there, right? So, how many null values are there? If I write just print x np dot is null, that is NA, and if I search for this X, uh, so is NaN is X, so NP is NaN. We are just searching up the thing, so we are finding that there are some true objects, there are some true results. So you can find out where this is giving you a true result. You can how you can write it, like okay, that should be there. So NP dot, where I'm going to see that NP dot is NaN of X to be true. So in the places of 2, 4 and 6 respectively. So X of 2, X of 4 and X of 6. All the three are the NaN. So in like in state of, instead of writing up this is NaN equals to true or false and then finding up the things, what we can write is that we are having X, right? So we can just write that print how many NaN are there. So X, inside this X, these are the broadcasting methods. Okay, no, sorry, these are not the broadcasting. We'll go with that. So inside this X, I want to see that is there something is NaN of X. How many are there? So we are getting some three NaN values exactly. So if we don't want to see the NaN values, if we want to see right here, we can, if we write a false here, then we'll be looking up for all the rest values other than the NaN values. So if I write that in the X, if we are looking the same statement, right? If you are searching for the same statement, instead of just writing up this, what we'll do is we'll just apply a negation over there, that we don't want the NaN values, we want the original values or the values which are there. So there are 10, 20, 30 and 40 apart from this NaN. Got it? Got my point? So there is 10, 20, 30 and 40 apart from this NaN. So that's the difference. Only the negation difference is there, right? That is how you'll be getting up the things. So like if you say that X is equals to U dot copy. After copying, I'm going to change the S type complex. So what is my U? U is going to tan 10 plus 0j.
So what
Yes.
did you put? Sir, what did you put before that NP? Line number 35. Line number 35. Yeah.
Negation,
before NP.
negation. That you can find the just above the tab. Okay, left side of your laptop or PC. Just see the tab, or you can just search for that 1 to 0 numbers just below the escape.
Yeah. So, but why to put that? I mean, the purpose.
That is to give the negation of this particular thing. That with this we are getting all the NaN values, right? So if we don't want to find the NaN values, we can give a negation. Like we write it that not of true. What is not of true? False.
Yeah.
Right? That is a negation of true, right? Exactly.
Okay. So for negation, we did that.
Yeah.
Okay.
So here we have created some X, the copy of this X inside this U, and then S type to the complex, and then we can see 10 plus 0j, 20 plus 0, and all the things over there. Okay, fine. So now if even if there is some NaN plus 0j, but still if we want to see that is there any complex, how many complex are there then? Is there any complex, then how many complex? So we can just write print in the U, we want to see that if U is complex, how many are there? Okay, inside the U and changing to the U is literally complex ones, and NP dot is complex of U is not giving any results. Why? Okay. All right. Because we haven't defined any complex number, because there is no such complex, right? They are all 0j, 0j, 0j. So uh, let's say so that is a problem. Okay. So we'll define it as 10j, 20j, some nan, 30j, 40j, and nan. They're like okay. Nan is not defined. np dot. Now this is my u, that is going to be 0 plus 10j, and now it is fine. Okay, so complex. Okay, so these are the complex numbers, that is 0 plus 10j, 0 plus 20j, 0 plus 30j, and 0 plus 40j. Only these. So how many negations? If we just go for negating the things, then we'll be getting up the nan. So not the complex. Apart from the complex, what are the things? Only nan are there. Got it? So this is how it works. Now, as you know, all right, how to add up any numpy array, how to go for the concatenations and all, and those are the silly things. So I'm not going to go for those things again. All right. Now we are going to discuss something about nd it. Right, that is np dot nd iter. That is exactly the nd iterations, or the iterations over the numpy arrays. So let's take an x which is going to be an array, and let's just make it starting from 0 to 60 in the intervals of 5, and then reshaping this in, let's say, so it's 60, and with the 5 we can reshape it in 3 by 4, or let's say 4 by 3. Okay, cannot reshape in 3 by 4, then okay. Let's look if it is correct or not. Alright, fine. So we are getting 0, 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, and 55. So all the numbers from 0 to till there, right? If you want from 1, even we could take up there, and 1, 6, 11, 16, 21st, 26, and up the things. Okay, fine. So we have got this x. Now if I say that for I in this x, print this I 1, 6, and you are getting the exact thing, but the only difference is this is an array and this is a kind of the number of iterations or the elements you could see up there. Okay, now also I'll make one y, which will be an array, and there I'll be writing it as something this. And again for I in this y, we are going to print the values of I, and that's it. 1, 2, 3, 4, 5, 6. So for what I'm trying to say that for a linear, or let's say for a one dimension array, you'll be getting the or you'll be iterating over the arrays as exactly like this what you have got. Like we iterate over the for loops, right? We don't expect the things in kind of a list and like this, right? Whenever we apply the for loop, what we expect the things in some linearities, right, in one particular line and all of the things inside there, right? Individual iterations over the objects. So here in the, let it be for a 2 dimension, 3 dimension, we'll be getting the results exactly like this inside 1 1 1 list, right? We don't want it like this. We want exactly the operations to be done like this. So there we can apply that nd iterations, which is the numpy dimensions iterations. So it will be iterating over the objects, breaking it to be a one single line, and you'll be getting in the things. So if I write for I in np dot nd iterations, basically used for iterating over the multi-dimension arrays. So nd iteration of this x, then you are printing your I would be getting all the values 1 to like whatever it is 56, okay, 1 6 11, and so does the things, right? That is how it makes possible. So this is your x exactly, right? 1 to 56. Now if I want to make a transpose of any array, so making transpose of an array, so we'll be printing up this x dot t, or even you can write np dot transpose this x. Okay, so like this we can just transpose any of the arrays. There are several new methods to find or to break down things in a single array. I'll be focusing on that, right? So let's just start up with all the array manipulation methods and we'll go with that. Sorry guys, practicing these things in your home, because that is important when you will be dealing with the panels, data structures and everything. That is being important. 28 one I haven't given to you. Okay, let me download this. Okay, so in the array manipulation, the very basic thing we learned was the shape. If you remember, np dot the shape. We learned this in the very basic thing, that if you have any array and you are printing and you want the number of rows and dimensions, you can write it like shape of the array to be 3 by 4, 3 rows and 5 columns. Who is this? I think the same one. Are you both same, right? Okay, let it be. We should continue, right? Like this, right? So reshape, shape does the thing, right? So from the shape we got to find something called as reshape, if you remember still, right? So just coming up with all this. So if I write that x dot reshape, then there is no probabilities for it's having 1 2 3 4 5 6 7 8 9 10 11 12 3 by 4, or let's say if we do in 6 by 2. Yep. So that is how we reshape of the things. Arabica B. Okay, so I'm clear that you would be clear regarding these things, right? Okay, now let's look to something else, that is flat, flatten, and such things. Now, what exactly flat does? It gives 1D iteration over the arrays. Remember, 1D iteration over the arrays. Let's say I'm going to write my y as an array, and or let's say and arrange from the numbers 1 to 7 and reshaping this from 2 to 3. So if you see my y would be 1, 2, 3, 4, 5, 6. Now if I write print x dot flat, x dot flat. Now what flat will do? I'll make you see three operations. X dot flat of 3, x dot flat of 4, x dot flat of 5. Okay, or x dot flat. Flat here function is not callable. Okay. Right. So 16, 21, and okay, this is y. 4, 5, and 6. So what it does, what you saw, if you are writing y dot flat of 3, you are getting 4, just the second number. If you are writing y dot flat of 4, you are getting 5. Flat of 5, you are getting 6. Now if I see the info of this np dot flat, no such things found. Okay, I think it would be there in the Ravel. Is there? So in the Ravel it is given, I believe, yeah. So what this flat does, it iterates over an array. Okay, iterates over, and then we have even the flatten. So we'll be going up with the Ravels, with the flattens and all. Okay, so it returns what Ravel does. Even we have printed, see this. So this returns a contiguous flattened array. What is a flattened array? Right, we'll be going. No worries. Okay. All right. Okay. So I believe that is quite okay with you, right? That is how we do up with the flats. So if I write that x y dot flat equals to 3, y. Okay, right? So clear to you, right? So it just acts similar to that full also, if you remember of that np dot full. So it just iterates over the objects you write up in your elements. But better than flat, if we use flatten, that would be much better, right? So if in place of this flat, but for the definition you'd be speaking of that, this is going to iterate over that 1D, one dimension arrays, right? Okay. 1, 2, 4, there's 3. 1, 2, 3. So let's now go with the flatten. Now what flatten does, it creates a copy of an array collapsed in one particular dimension. One particular dimension means that if you see your y, what is your y? This 3, 3, 3 and 3, 3, 3 now, right? That is how what is your y exactly. Okay. Now, so in place of this, if I write that what is my x, if I see my x, all right. So here if I write the flatten, np dot flatten. So flatten of x will give you, what is the problem again? FLATTEN, flatten is not working. Okay. Then write this print x dot flatten, and that will work. So what you are getting is all the numbers in a one dimension array. Got it? So there are several methods for printing any numbers in a one dimension array. Next we have np dot ravel. So I think these are not included in the documentation. There is some not done by, don't need. Alright. So what is the ravel of this X? Again the same thing. Okay. And also one more thing is there. If
So what is the difference between flatten and ravel
yes,
function? What is the difference between the flatten and ravel function?
see what ravel does, it gives you a contiguous array, right? And what flatten does, it gives a copy of an array. Okay, that's the only difference, right? If you see that wait, 1 minute, underscore np dot what I was trying to say, reshape, yeah. So if you see np dot info of this np dot ravel, so you might have seen in there that it returns your contiguous flattened array, right? That is a 1D array containing the elements of the input, and a copy is made only if it is needed, right? Only if you define then only. But in the flatten, what happens if you write up for the flattens? It basically gives you the copy itself. Why this is not working? Okay, fine. So what exactly a flatten does, it returns a copy of an array, and that to collapse in one particular dimension, right? One dimension means that even if you write it as np dot what to say, let's say you're writing a dot flatten, x dot flatten, and you're using f. So what you can see, an array that is being flattened, right? That is being flattened, and you're getting the elements. Now, what this F C K means, I think you have read it there, because I have said that this F stands for the Fortran contiguous, right? You have C for that C major styles. F no F, F stands for this flatten, and this what is there? Another thing is, I think that is K and S. Yeah, K is there, I think. So the various things are having various options. If you can see the documentation, you will be finding up there, that is C, A, K, and one more is there. What is that? C, A, K, and F. Okay, these are the things. So C, F, A, K, C, A, K, F, whatever you remember, right? Whatever the things you could remember, that is being done. So remember what Ravel does. If I just give you written things here. So Ravel operation is to return you a flattened array. Okay, and flat is to basically a 1D. We can say iterator over the array. And then what we discussed, flatten. So flatten is to return a copy of the array, one dimension. Okay, so these three things have these three features, right? So don't be confused with this one. Okay, now okay, I was talking about reshapes. Clear to you? Who asked the question? Anyone asked the thing? I think that would be clear to you. So what is reshape? Okay, reshape, I think we have discussed. I was saying that if I write print x dot reshape, to any such things will be done, right? But if I write reshape of any negative number, let it for anyone, okay? So apply any negative, then what happens? See, it goes on printing up the things in a reverse way, or you can say it just goes and print every individual element of the array in one dimensions. It bring it in a one dimension. Okay, that's when you write up things in a negative. Right? It can be negative 1, 2, 3, whatever you write. That is me. So we have three particular steps, right? You can even write negative reshape of any array to bring that in one dimension. You can use the flatten, you can use the ravel, and what more is there? Whatever you can write the things in one dimension exactly. You'll be getting one dimension. Okay, cool. Moving up. Next we have transpose operations. So have you got all the cheat codes? That this one, you got this in your drive. They have all for the Seaborn and all. Yes, speak up, guys. Got this? No, thanks. No. Is the screen hanged for the people? Okay. Wait. So is it hanged? 1 minute. Stop presenting. Present now. Entire screen. Share. And done. Can you resend in the drive? Exactly. I could do. You are from here. No. You are from here. File, upload, open, load. Done. Okay. Yeah, so talking about the transpose operations, the very first one I showed you, right? That is np.transpose. And what it does, it permutes or reverse the dimensions of the array and this give you a transpose. Whereby I write that x is equals to np dot an array, and if I write the two-dimension array there, let's say 1, 2, 3, 4, 5, 6. Yeah, so does. Now print. See, reshaping is something different and transposing is something different. So don't get confused with this. So transpose will be 135246. What is the original value of x? 1, 2, 3, 4, 5, 6. Okay. Got my point? So reshaping is always different and transposing is something different. Always, remember. So if I write np dot and arrange of the numbers till the 4 and reshaping it to 2 cross 2. I believe that will be done. So let's see what y comes. 0, 1, 2. Exactly. Yeah, so 0, 1, 2, 1, 3. Okay. Now if we say that we want to see a transpose of this y, what would be there, guys? Say answer. What will be the transpose of this y? Answer quickly. Transpose of y.
So 0, 2, 1 and 3?
Exactly. 0, 2, 1 and 3. Okay. Cool. Nice. So that will be just a transpose. Okay. So transpose is clear to you, right? Okay. Now, similar to that, we have swap access. What swap access does if we write np dot swap access. So with the name only, you can see that the access will be swapped, right? That is, interchange will be done in the x and y, or you can say the rows and the columns, right? We write that we want to do the swapping of this x's of this y. Missing 2 requires a positionals. Okay. let's make an array for this. So this is 1, 2, 3 and 4, 5, 6. And now we are going to swap this y with 0 and 2. Okay. What do you got? What do you have got? 1, 4, 2, 5 and 3, 6. Right? In the 0 column, in the 0th row. Right? If you see a y of 0, what is that? 1, 2, 3, 4, 5, 6 in equal depths. So write np dot info.
So what is reshape of 2 cross 2 does?
Reshape of 2,
2 comma 2.
2 comma 2. Okay. So that we are just reshaping it in 2 rows and 2 columns. Let me make you more.
Okay, sir.
Okay, fine then. Swap access, and there you can see of the things. So what it does, what is swap access does? Interchanges the two x's of an array. So first is your array input, what array you want to change. Then you give the first axis, which what is the first axis and what is the second axis. That will be an integer. Then it returns your swapped array in the array. Okay. So if we write x is equals to np dot array of 1, 2, 3, something like this. Okay, swapping the arrays. So this is the array I want to swap, that is x, and this is my first row, that is 0, and the second axis to be 1, and then you'll be getting up the things. Then that will be swapped up, right? So one row will be coming up there, right? That is 1, 2, and 3, and so does the things will be done in the swap cases, right? That is how.
So then what is 1? 0 comma 1 is what, sir? What does that 1 denote?
That is your x's. Always you have two x's, right? That is 0 and 1. So if it is 3, 1, then you will be having 3 x's, 0, 1 and 2. If you see other things here, where is that? Numpy. See, the x is 1 and x is 2 for the 2D array. For 3D arrays, x is 0, 1 and 2. Got it? X, y and z, and then x and y of just a quadratic, what is that called as? A graph you
Row
take
and
it.
column.
Yeah, row and column.
Okay.
That like we represent it, if you remember that concatenate, we write x is equals to 1 for this row, and like for the column we have written it as x is equals to 0, right? So that is the x's. And here in NumPy we call as x's, and also everywhere we call it as x's. The rows and the columns when we are talking about. Okay. And similarly, if we write the np dot transpose, not np, like y dot transpose. So whatever the things you write, you'll be getting a transpose of all. All right. That is how it, do the things. All right. Now coming up to the next. So I believe things are very clear. Item size, shapes, and all. Okay. In space we have seen, right? Yeah. Okay. So lin space, log space has been done, right? So now going for a graphical representation. So just to see you that how things are made up. Okay. So for a graphical representation, I'll have to import the matplotlib. We'll study it later. What is it? How it does. So we'll import this matplotlib as plt, and now let's take up some things, right? Let's write this is going to be the zeros of 8. Right. So my first coordinate q1, or my first variable to be like np dot linspace. From 0 to I'll be taking the numbers till 10, and I want some 5 numbers. Number will be 5, and that is starting from 0, stopping at 10, and now endpoint I'm going to give it as true. Endpoint, you know, right? The endpoint, if you write true, then exactly your linspace value will be stopping at 10. If you give false, it will be not stopping at 10. It will be stopping before the 10. The next is my q2, and let's take it as np dot linspace starting from 0, stopping at 10. Number we need is 5, but the endpoint is to be false. Okay, you'll see the difference, and let's just plot the data of this q1 with respect to y and giving it a red color. Let's just see. So this is your data, exactly a line where these things are being plotted. So if I write I want some red dots, so these are the red dots or the values what we are getting. So let's increase the thing. Let's say this is going to be 15, and this is now becoming as 15, and we'll run this, and this is same thing. Okay, quite good, right? So now also we'll be plotting. Let's take q2 and let's take with y plus 1. Okay, so whatever the y value will be there, with that one more. So if it is equals to 0, it will be 1. If 1, then it will be 2, and so does the things. And also we'll be discussing this in the matplot level, how we do with all these things, right? And also I'll be setting my y limit from minus 0.5 to this 1. Okay, what exactly this means is, like, I'll show you. So now to show up things, and we'll run this. And function objects of y limit is not callable. Okay, so what you can see that if it is not working, your limits are working from 0 to 1, right? Now if I set my limit from minus 0.5 to 1, then you can see that it will be going coming from minus 0.5, and then you'll be seeing other things. Now I'll be making it as 0.1. So minus 0.1 to 1, and so does the thing we are getting. So instead of 1, if I'm writing it as 5, so my limits will be from minus 0.1 to 5. So let's take it from 1.9. So that's the graph. And what you can see up there in the orange one, you can say, like, if we write up the labels, even here, if we write that labels is going to be let's say q1 versus y, and here labels is going to be q2 versus y plus 1. Okay, so these two graphs all right. So we can see up the label, that is blue one stands for the Q1 versus Y, and this orange one stands for this Q2 versus Y plus 1. So what is there in the Y plus 1 and all, what is there in the Q1, Q2? So if you see your Q1, if you see your Y even, so what is that? It is all about the 0. Why it is 0 now? Yeah, sorry. So this is all about the zeros. Okay, so NP dot zeros of 15. So 15 zeros are there. Now what are these Q1 and Q2? So here you have made a lens space which starts from 0, stop at 50, stop at 10, and you are expecting 15 samples between that, right? And endpoint is true, exactly. So if you see your Q1, that will be starting from 0, ending at 10 exactly. But in the second line, we have written endpoint equals to false. So if you can see up there, the same things are there, only there is a difference in the endpoint. So here we are getting our endpoint value starting from 0 but ending at 9 point something. Okay, not at 10. We'll be getting everything same, but the only difference will be it will not end at 10. It will end before the 10. Okay, that is the difference between the endpoints. Okay, so I plotted up the data, and that is how it works basically. Okay, fine. Moving on. So I think you also know about the rounds and all, how round off works here. Like these are the Python basics exactly, right? So in Python we learn these things, round and all. So if I write that np dot, so this basically round off the numbers, right? How we say rounding off to some 2, rounding off to 3 and all. If we say round off 16.055 to 2, then 16.06, right? And nearest round of numbers and all, we make it there. So that is a np dot round. Okay, but if we say only the round of 16.055 to 2, you see at 16.05, right? So what it does exactly, what's the difference between the things then? So round an array to a given number of decimals. Got it? np dot round, what it does, rounds an array to a given number of decimals. And what round does? It round a number to a given precision of in a decimal digits. Okay, so that's the difference between the basic round and the numpy round. So the difference you can see up there. See 0.55 to 2, we're getting it rounding off to 0.6, but in case of a round, it will be working at 0.5. Okay, so there are very similarities in the maths also. If you see maths.fabs or frexp, or let's say for the abs, or a lot of things are there, right? So I think that full and empty and this all empty alikes and such things are clear to you. Okay, and the basic operations of the numpy are also clear to you guys, right? So element wise doing like all the element wise product or additions, multiplications, subtractions, and all such things. I believe that would be clear to you now, right? So now let us go and see some things regarding that what is called as choice. So in the random, we'll be looking up for the choices. Okay, fine. So what is exactly choice means? Choice means that what the elements we want from our type, right? So if we are having a set of elements and we want only that elements to be given in the random state, right? Even if it is a random state, we want only those elements there, then we can write choice. So that is np dot. So it is to be brought from the random because it is one of the function of a random choice. And so what are the perimeters we are having? Sorry, not perimeters, I'm saying the parameters we are having here. Okay, so that is, if you see up there, So is it for the choice or something else? So it says that it generates a random sample from a given 1D array. Alright, so parameter, it takes A, it takes size, it takes replace, it takes P, and then it returns you something. So what is A? A 1D array you like to give, and that will be an integer. And then the size you want to give it, and then the replace, that is boolean and all whatever you want, and P stands for the probabilities or the percentage value you say. Okay, so what are the things you'll be getting up there as much you write? So let's just take one such expression from here, and let's just take it from this. Okay, paste, replace false, and just remove all these things. So that's the thing you're getting. Okay. 0.4 and 0.6, and A and P must have same size. Okay, A is for 5 here. 5. Okay. So it was like till the 5 they need some, like they only need this 3 to be printed up there, and the size was according to that, and they need only some numbers to be printed over there, and there's some 3 numbers with some given percentages, some 5 percentages with that. Okay, so what do we write, right? If we make our own one, so I'll be writing it as random dot choices. So I'll be making it as random dot choice, and then let's say it to be 2, 3, 4, 5. And I'm going to give my P will be equals to 0 0.2, 0 0.3, 0 0.3, so it is 5 now, okay, 0 0.1, so 3, 2, 5, 1, 6, and 0.4. And I'll be mentioning my size to be 50. So what you can see here, don't go with the above ones, right? We a bit confused with that. So random dot choice, you write first the array you want, and then you write the probabilities you want, and also the size you want. So like you are getting every elements between 2, 3, 4, and 5 itself, right? Nothing else is there. And what is this 0.2, 0.3, 0.154? These are the probabilities. Like 2 will be printed only for 0.2%, right? 20% you say. 3 for only 0.3, 4.1. So you can find the 4 occurrence will be very less as compared to everyone. So 4, 4 only for 2 times, 3, 4, and okay. So 4 is for 4 times, right? That is how it is being made. Alright? Okay. Okay, so similar to the list, there we have various functions like inserts and all, and that is today we'll be ending up with the numpy. And tomorrow we'll be having a test on this. So np dot insert, what it does, if I write np dot insert, and if I say that I want to insert something in an array, right? So if I define an array and I want to insert something there, so let's say let's make an array. X is going to be np dot array of, let's say, an range of some 16.0, and reshape this to 4 by 4, or in the 2 rows with the 2 columns and rows, you can reshape with that too. Okay. So if I'm going to insert something in my X, okay, let's first see what is there in the X. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 13, 14, 15. Okay, that's nice. Alright, let's change this X. This will not work there. So if we write 0, 1, 2, and 3. Okay, and now I think this is fine. So now if I just want to write or append or insert or delete whatever we did in the list, the operations what we performed in the list, if I just want to write the same things, so I write np dot insert, and let's say in the x I want to insert in the 1 and 5, and the xs is equals to 1. So in the 1 I want to insert this 5, got it, right? So in the first place, you say in the first column, right, I want to insert 5 and the x is to be 1. So we can see in the first column it is going to be replaced by the 5. If I see my x, okay, that is, it was 0 1 0 1 and 2 3, so it is being inserted over there, not replaced, sorry. So it is being inserted, so in between this 0 2 and 1, so in the first place I want to insert 5 and that is being inserted. If you want you can change it other things as per your choice. Okay, so if you want to delete something, you can even delete after things, right? np dot delete. In the x you want to delete from the first one, that is 5. Okay, sorry, foundations are there, so go for the 0. So 0 and 1 to be deleted from the 1. Got it? Clear? So that is being done, right? Because this is not we have made, right? If we just see our x, that is still having 0 1 and 2 3. So if we are deleting from the 1 and the 0, right? So x is 1, we are deleting of the 0, but we are deleting this first row, that is being deleted, right? This mean gives you the x's. If you write 1, then it would be obviously 0 and 2, that the columns, and if you write 0, that would be obviously going to be a row. Got it? That is how it works. So it's very clear, I think. Okay, that is random, and I think we did the unique. Yeah, so we have done the unique one. So that is how we go with the numpies, and I believe that now we have completed our numpy, right? So whatever the things will be there, all the operations, I believe now you could do operate, and you can do a lot of things with the numpy, right? Sine graph, cos graph, to see everything we can do with that.